Hello, my name is Çağın Şekerefeli. I'm a first-year physics major studying in Bilkent University. I'm going to present my experiment about the relationship between the varying coil turns with electromotive force using Faraday's law. The objective of this experiment is to investigate the relationship between the coil turn, which is denoted by N in Faraday's law, and the electromotive force, denoted by EMF, that appears when the magnetic field changes. According to Faraday's law of electromagnetic induction, as an electromotive force, EMF, is induced in a coil by a fluctuating magnetic field, the pace at which the magnetic flux through the coil changes is directly correlated with its produced EMF. The generated EMF rises proportionately as the coil's turn does. More turns essentially translate into a larger magnetic flux shift for a given variation in the magnetic field, which raises the induced EMF. Therefore, we can say that when there are more turns in the coil, the magnetic field line density increases, and so does the magnetic flux. The induced electromotive force is going to be greater when there are more turns in the coil. In this experiment, I had 4 coils with turns of 10, 15, 20, and 25, which I taped on the ruler at the 10 cm mark every time. Then I dropped the magnet with the bolt on top of the magnet for support so that the magnet does not rotate from the 15 cm mark so that I could regulate the speed in which the magnet passes through the coil. I connected the 2 ends of the coil to the multimeter using cables, and I took 3 measurements of the EMF in millivoltage in each coil. I'm collecting the data as shown in the videos, and for the 10 coil turns, I took 3 measurements, and I took the mean value of the EMF in millivoltage, which is 2.6. For the 15 coil turns, the mean value of the EMF is 3.6. For the 20 coil turns, the mean value of the EMF in millivoltage is 7.13, and for the 25 coil turns, the mean value of the EMF is 9.63. My independent variable is going to be the number of coil turns, and my dependent variable is going to be the EMF in millivoltage. The slope of the EMF versus coil turn graph gives the rate of change of magnetic flux with respect to time, which is approximately 0.34, and positive, indicating that the EMF and the coil turn value is directly proportional. To find our error percentile, we will take the N and EMF values using their ratios to each other. First, the ratio of 2 different N values, and then the ratio of their experimental EMF values. Since N is directly proportional to the EMF value, the ratios should be the same. We will then compare the experimental ratio to the theoretical ratio to find our error percentage. Our rate of error increases as the coil turn increases. We can devote this to the fact that as there are more coil turns, the more energy will be lost in the turns, and the symmetry of the coil will be more disrupted as they are hand-winded.